Hi guys, welcome to today's lesson. So today we're going to be looking at proofs of parallelograms. Firstly, we're going to look at what makes a quadrilateral to be a parallelogram, and then look at those properties and try to use them to then use the proofing of what a parallelogram is, right? So that you can write out that proof. But please remember, guys, whenever you're doing geometry, you always need a two-column table. First column, it is all about the statements that you are going to make. The second column will be the reasons why you think those statements are valid. So at all times, you need to make a claim, which is the statement, and then give me a reason why you think your claim is correct or valid. But for now, let's look at our leading question and then see how we can prove that a quadrilateral is a parallelogram. So as I said, my question is, how can you show that a quadrilateral is a parallelogram? What are the building blocks of a quadrilateral being a parallelogram? That's what you need to be thinking about, because that's what we are actually going to use. Let's just go through what geometry is all about. Remember, you always need to read through the facts part. This is about what the statement is telling you, right? In the quadrilateral, this side is equals to that side. And then because they have told you that, you will then mark that equality on your diagram, because everything that is given as a fact needs to be seen on the diagram. Then you mark the implicit facts. These are between the lines, right? So when I tell you that these lines are parallel, I am not giving you the properties. The implicit of the lines being parallel will be the properties of the parallel lines, your corresponding, your alternate, and your co-interior angles. Then you also need to read through the facts part. This has to do with what is it that you were given based on the implicit facts that we are talking about, and then you need to devise a plan of action. You also need to evaluate and then restart again. Now, the terminology that you're going to look at here is the implicit. Remember, I said this is normally the between the line, right? Between the lines. So a typical example that I gave you, if I say to you AB is parallel to CD, you know that you can think about corresponding angles. That's the implicit thing. You can think about the alternate angles. You can also think about the co-interior angles. So these are not given from the get-go. The only thing I told you was that the lines are parallel. So the implicit part will be these three properties that I've just mentioned. Then also you have the word deduce. To deduce would mean to make a conclusion. So this will be make a conclusion based on what you have done in terms of your working out, right? Based on your working. Based on your working. That's what you are making a conclusion based on your working. And then what we then need to look at firstly, as I said, are the properties of a parallelogram. So remember, a quadrilateral becomes a parallelogram if both pairs of opposite sides are parallel, right? Not just one, no, both pairs. And then also both pairs of the opposite sides are also equal. So this is option 1, by the way. This is option 2. Then option 3 will be both pairs of opposite angles are equal. That will be my number 3 that I can try and prove. Then you can also prove that the diagonals bisect each other, because that's one of the properties of what a parallelogram is all about. Now, how to prove that a quadrilateral is a parallelogram? I have 5 options for you, right? You can prove the both pairs of sides to be parallel or to be equal. The both pairs of the angles to also be equal, but they must not just be any pairs of angles, right? It must be the opposite pairs, right? Not just any angle. Then you can also prove that the diagonals bisect each other. Now, the additional thing from the properties of a parallelogram is that you can prove that one pair of sides are equal and parallel at the same time. So what do I mean? If I say this is a quadrilateral, A, B, C, D, and I want you to prove that this is a parallelogram. If you can prove that AB is equals to CD, and also prove that AB is parallel to CD, then this will definitely be a parallelogram. But you can't say AD is parallel to BC, and then that's 1 point. And then your second point is AB is equals to CD. That does not mean anything, because there are a lot of shapes that have that particular property. Also, remember that whenever we talk about congruent triangles, right, this is not a direct way of proving a quadrilateral to be a parallelogram. But we can use this to try and talk about equal angles or equal sides in that particular shape. That will then take us back to my 5 options that I've given you of both pairs being parallel, being equal, the angles being equal, the diagonals bisecting. So you can use congruency to try and apply one of these options that I've given you here. Now, when you are proving parallel lines, because that's one of the other properties I gave you as an option, you need to be able to know that how can 2 lines be parallel to one another. And there's many ways to do this, right? You can use what we call the converse theorem of parallel lines, meaning you can prove that the corresponding angles are equal, right? The corresponding angles, remember, that's like an F shape. You can prove that the alternate angles are also equal. That is your Z shape, not your U shape. So this is more like your Z shape in the diagram. And then lastly, you can try and prove that your co-interior angles are supplementary to each other. Now, a very fun thing, guys, that I actually saw sometime when I was looking at this. One person once said, these lines are parallel because it is the F property in the word fun, right? Because we normally shorten the properties of parallel lines to be fun. Please don't even try to do that. The F property does not exist. It's just a shortcut so that we help you remember how to then mention the properties of parallel lines and how to visually see them on shape. So please don't try and do such things for us. Now also, in terms of diagrams of how these angles look, remember the red and the red there will be the corresponding angles. The purple and the purple will be the corresponding angles. So in simple terms, this will be my F that I was telling you about, right? Or my F will be this one going down, facing the right-hand side, right? Where you talk about the corresponding angles. But when you are trying to prove that the lines are parallel, please don't mention corresponding angles and leave it there. What about corresponding angles? They need to be equal in order to qualify those 2 lines as parallel. The other one is the alternate angles. Remember, you need to say that the alternate angles are equal in order to qualify maybe line AB to be parallel to line CD, if that was the requirement in that particular regard. So this will be red and red, those are equal. Purple and purple, those will be equal to one another. And then my Z shape that I spoke about will be like this, right? So this will be the Z shape that I spoke about, and this will also be the Z shape, my wobble that I'm gonna make for you here. Right, so that's how you look at the alternate angles. Also, you can try and talk about the co-interior angles, but please don't make the mistake of thinking co-interior angles are equal. They are actually supplementary, right? And remember, supplementary simply means that they add up to 180 degrees. Add up to 180 degrees, right? So if this angle here and that angle there add up to 180 degrees, then we will say that these are co-interior angles. And also if this angle here and that angle there add up to 180, we will then say that they are co-interior. So some people make the mistake of, because the first two properties are about equality, even when they get to co-interior angles, they think equality is what we need to look at there. So guys, please make sure that you understand what will make the quadrilateral to be a parallelogram, right? And one of those properties is to prove either the sides to be equal, to be parallel, the angles to be equal, the opposite ones that is, the diagonals to bisect each other, or you can just use one pair of sides and prove that they are both parallel and equal to one another. We're going to apply this when we come back from the ad break, but for now, I just want you to digest everything that we've spoken about, and when I come back, I'll then try and apply this for you so that you can see how do you go about doing these proofs that we need to do. Please stay tuned, I'll be back just now. Hi guys, welcome back. So as I promised you, I said we are going to apply what we've looked at in our first segment in terms of the properties of parallelograms, right? The properties of parallel lines and the properties of congruency as well. So now we're going to try and put this into action by solving one question or two, just to see exactly what we are talking about. So let's just go straight to the first question that we need to do. So here they're saying to us, in triangle FGH, right? This is a triangle FGH. J is the midpoint of FH, right? J being the midpoint of FH makes FJ to be equals to JH, right? Now that's one interesting thing, because you can see we might be talking about diagonals somewhere there. And then they say to us, GJ produced intersects the line through H, right? So that's just to tell us it is a straight line, and this is parallel to GF in I, right? This would be parallel to GF, which is this line there and that line there, right? Now, based on that, I can now add a few things, right? Remember when I said the implicit facts that you need to know. Since these are parallel, I know I can claim that this line, this angle there, is equals to this angle there, because it's alternate angles, right? I can also say that this angle here is equals to that angle there, which is also alternate angles. It's actually H2, not H1, right? And that will still be, the reason will be alternate angles, right? So you can talk about those. And then this one here, I know that this will be equal to that one because it's vertically opposite angles. So far you can see I have now a lot of other things, 3 more things that I added based on the fact that I know the lines are parallel to one another. What they want us to prove is to prove that FGHI is a parallelogram. So the whole shape is actually a parallelogram. So how do we go about doing that? Firstly, we read through the information and indicate all the equalities as I showed you, and this is how the diagram will look like. And I promise you, if you don't start here, then you won't have a proper plan of action in terms of how to prove this concept of parallelogram. Now, you're going to choose a possible method to prove that this quadrilateral is a parallelogram, and I'm going to give you a few options that you are going to try and choose from based on what you are given, right? Now, my options are, I can prove that both pairs of opposite sides are parallel, remember that, right? So not just one pair. So I must prove that this side is parallel to that side, and this side on the left is parallel to the side on the right. Then I can claim this is a parallelogram. I can prove that the sides, both pairs of opposite sides are equal, so the side at the top and bottom are equal. On the left and on the right, are also equal. If I can do that, then I will say this is a parallelogram. Or I can prove that the opposite angles are equal, both pairs. So meaning the one by the top left corner and bottom right corner there, and the one by the top right corner and bottom left corner there. You can then try and prove those to be equal. If they are, then this is a parallelogram. Now, the one that we saw that might be the way that we're going to take is to prove that the diagonals bisect each other. Why am I saying that? Because already we were told that one line is bisected, right? Now, if I can prove that this other line is also bisected, then I can say the diagonals of this quadrilateral bisect each other. And then the last thing that you can try and prove is just to use one pair of sides to prove both equality and to be parallel to one another. Now, please consider trying to prove the triangles that are to be congruent to one another. And remember, the congruence that you are proving, it is not necessarily just to talk about congruence. No, this is because we're trying to prove equal sides from congruence, or we're proving equal angles from that congruence, right? Because remember, if two shapes are congruent to one another, it means all the corresponding sides and angles will be equal to each other. Now, let's try and do this together and see exactly how we can prove that this is a parallelogram. So firstly, what do I know? I know that I am going to specifically limit my focus to a specific triangle. So I will say in triangle, all right, so I will start by firstly telling you which triangle I'm focusing on, which is FJG, and in triangle IJH, right? So I'm going to look at what if these two triangles are congruent to one another. If I can, I promise you, then I can claim that GJ is equals to JI because of congruence. So let's try and do that just now. So in FGJ, I know that F1 is equals to H2, right? And this is going to be because there's alternate angles, and you need to specifically tell me which lines are parallel, right? Which is FG parallel to IH. Also, I will then try and say the other angle that I have will be G1 is equals to the other orange one, which is I2. Right, this is I2, and my reason will be the same as what I have, right? Alternate angles, and this is because FG is parallel to IH, right? So this is IH, not IF, IH. And then from there, I can use one more side that I can find, because I can't use three angles. Remember, three angles is not congruency, it's similarity. So I will use this given side of mine to say those sides are equal. So this will be FJ is equals to JH, and this will be because I was given that that is the case. Then I can claim that triangle FGJ is congruent to triangle. So now the angle at F is corresponding with angle at H, the angle at G is corresponding with the angle at I, then it means the angle at J will correspond with the angle at J. So because of this, I can then say that my GJ is equals to JI. I promise you, saying this GJ is really a very funny thing to say, because now it's like two letters that kind of they have the same sound. Anyway, so this, my reason will be from congruency. And then lastly, I will then say, therefore, triangle, and not triangle, quadrilateral I mean, because now we're no longer focusing on the triangle. Quadrilateral FIHG is a PAM, right? PAM means it's short for parallelogram, by the way. And then my reason for this will be diagonals bisect. Diagonals bisect each other. Bisect. And that's how I can then use congruency to my advantage. But now let's see, if I did not know how to do this, right? If I did not use the concept of diagonals, what else can I do? Remember, one of the options I had for you was we can talk about one side, one pair of sides to be parallel and equal, right? So already I am given that they are parallel. So if I can prove that FG is equals to IH, then I would have proven that this is a quadrilateral. So the same thing as what I've done with the previous example, right? You will prove congruency. So you will find that triangle FGJ is congruent to triangle. The F corresponds with H, remember that, and this corresponds with I, and that one with J, right? And your reason is still the same, angle, angle, side, because I will still use the same process as the previous example. And then from there, I can then say FG is equals to IH. And my reason still will also be from congruency, right? You don't write congruency in full, just the three horizontal lines. And then as a result, I will then say that my FGHI, right, is a PAM. Now the order in terms of how you go with, in terms of your labeling, does not really matter, as long as you start at one point and go with the points and not jump any point. And my reason for this will be one pair of opposite sides are parallel and equal to each other. Because of this, I will then have claimed that this is a parallelogram. Not by measuring anything, guys, because I know you are very creative. You'll start using a ruler to measure the sides. No. We're going to use the main concept of congruence to try and talk about equality in these two shapes. And that's how you can then prove that a quadrilateral is a parallelogram without mentioning the word parallelogram in your proof, only as the final statement, because that's what we want you to do. All right, guys, that's all I have for now. I want us to take a quick ad break so that when we come back a bit refreshed, we can then look at some more problems together. Please stay tuned. I'll be back just now. Hi guys, welcome back to our lesson. So we are still looking at the proofs of parallelograms, right? So mainly what this is all about is to try and look at what are the properties of a PAM that I can try and apply in trying to prove that any quadrilateral that I'm given at any point is actually a parallelogram, right? But that is mainly because of what makes a parallelogram to be a parallelogram. Not just because you know that this is a quadrilateral and it looks like it is a parallelogram, then you will say it is a parallelogram. Funny thing is, some people do that. They look at it and say, yes, it is a parallelogram. They arrest it because it looks like it. Please don't even try that, right? You always need to work out and show me your proof why you think it is a parallelogram. So let's look at some more questions that we're going to try and solve. That these ones are a bit more complex because now there's more additional stuff that you need to do and there's more implicit information that you need to be able to see without you being told. So let's look at the question. So this says the angle bisectors of L and N, right? Angle N and angle N of parallelogram KLMN meet diagonal KM respectively in O and P, right? So in simple terms, they're saying the angle bisector of L meets O, right? And the angle bisector of meets the line at O, and the angle bisector of N meets the line at P. That's what the word respectively means, right? So this is number one, so this will be number one. This is number two, this will be number two. So the word respectively just does not mean just respect or anything like that. It just tells you to follow the same order that we gave you in the previous statement. Now we are required to prove that OLPN, right? So let me just show you. It will be something like this. So they actually want us to construct a quadrilateral there, which is going to be OLPN, and we need to prove that this is a parallelogram. Now, what do I know here, right? I know, number one, that I have an angle bisector making N1 to be equal to N2, right? And also L1 to be equals to L2, right? I know this. I also know that my L1 will be equals to, I don't have anything equals to L1. I actually have K1, that's what I wanted to talk about, is equals to M2. And that's because of alternate angles that we have. And also this one here will be equals to the angle that it makes with the same transversal with the parallel line, right? So which is M1. So these are the things that I know so far. Now I'm going to try and use all of this that I've just added here to prove that this shape in the middle is a parallelogram. So let's actually look at it. So firstly, I'm going to show you the nicer version of my diagram so that you can see these arrangements and these relationships based on what we are given, right? So I know K1 is equals to M2. I said that's alternate angles. I know K2 is equals to M1. That's also alternate angles. And then my red there will be the angle bisectors. All right, so to apply all of this to try and prove that the middle quadrilateral is actually a parallelogram, we are firstly going to focus on this triangle here, and then we are also going to focus on that triangle there, right? So I'm just going to write them down. So in triangle KOL, and triangle NMP, N for no one, and M for money, and P there, right? So I must prove that in this triangle, this side and that side are equal. If I can do that, then I will be one step closer to also proving that this side is equals to that side, right? So let's quickly look at that. So I know that in these two triangles, my K1 is equals to my M2, and this is because of alternate angles, and this is because KL is parallel to NM. And then from there, I also know that my L1 will be equals to my N2, right? Remember why this is the case, because of the fact that there's a bisection of the angle, right? Remember the opposite angles of a palm are equal to each other. So if they are bisected, it means they are both cut into two equal parts, right? Bisection of opposite angles of a palm, right? And then I need one more thing, and that one more thing needs to be a side because I can't use angle. And that side will be none other than KL being equals to NM. And this will be because its opposite sides of a palm are equal, right? Opposite sides of a palm are equal. Please remember, guys, as I'm using this palm, it's actually short for parallelogram, right? I just don't want to write the whole. And mathematically, by the way, this is how we do write it. So as a result, I will then say that triangle KOL is congruent to triangle. Now K goes with M, so I have it there. And then my L goes with N, so it will be the N there at the end, and then P, so MPN. So because of that, then I will claim that OL is equals to NP, right? And this will be because from congruency. And then now I have killed one bird, right? This one. Guys, don't kill birds. I'm just joking when I say I killed one bird. So I have actually solved that OL is equals to NP. Now I want to show that ON is now equals to LP, right, for leopard. If I can do that also still using the concept of congruence, then I would actually know that these two shapes are, that shape is a parallelogram. Now I'm just going to show you on the diagram, right, because then you will be able to see it. So it means this angle is going to be that angle, equals to that angle, right, because of properties of congruent triangles. And if that is the case, then I also know that this angle here will be equals to that angle there, right? And my reason for that will be adjacent angles on a straight line. I know that this is a common side, right? And then also the last thing that I know will be what? I will know that this side has been proven to be equals to that side. So now I have side, angle, side. So I'm going to write it down for you to be able to see it. So the first thing I said was O2 is equals to P1, right? So this is going to be O2 is equals to P1, and this will be adjacent angles on a straight line, angles on a straight line. And then from there, what else do I know? I know that OP is a common side. So OP is common. OP is common. And then the last thing that we want is to say OL is equals to NP. So OL is equals to NP, right? And this was proven above, right? So this is proven. And then as a result, I will then say that triangle, let's quickly look at it, triangle OPL. Triangle OPL is congruent to triangle. Our O, we said, goes with P, and we said our O goes with P, and that means the L will go with the N, and then the P will go with the P with the O, right? So it will be the P will go with the O with the side, and then the L will go with the N. And then from there, this is because of side, angle, side. Then I will then claim that my last thing that I wanted to actually do because of this was to say ON is equals to LP. ON is equals to OP, right? Is it OP or LP? ON is equals to LP, not OP, LP. Now, my reason for this will be again from congruency, Then as a result, I then conclude my O, let's just go back, OLPN. OLPN is a palm, right? My reason for this will be both pairs of opposite sides are equal. And then that's where you will end it. So I know this is a lot of work, guys. That's why I said to you, this is a more complex one that we're going to do. But congruency seems to be the very useful tool that we're going to use to prove equality in terms of shapes that we have, because congruency is easier to prove than any other property of shapes in mathematics, especially geometry. So just make sure that you are clear on that, right? So you first use congruency as a rule, and then as a tool, and then from congruency you can claim that certain things are equal, and then as a result you can claim that the shape you want is a parallelogram, given that you have proven one of the 5 options that I've given you when we started this. So guys, I hope that is very clear and you can understand this. I know it's a lot of O's and L's and N's there, but I believe that as I was writing it down, you were also writing it down and you managed to understand what we did. If not, please do some research from your textbooks, from your internet, so that you can understand it better. But for now, I want us to take a quick ad break, then we're gonna do one more question that is going to try and apply these rules that we've been talking about. Please stay tuned, I'll be back just now. Hi guys, welcome back from the ad break. So we are now in our last segment for the show. Here we are going to also try and prove that a quadrilateral is a parallelogram, and then try and prove that 2 line segments are equal to each other based on the fact that we know that that quadrilateral is a parallelogram. So let's just look at what the question wants us to do and then try and apply those things in the diagram. Now, what do I know? So they say there is a parallelogram LOQR. What that simply tells me, it tells me that this line is parallel to that line there, right? As you can see that I've showed you with an arrow. But now, the interesting thing that they're telling us here is T is also the midpoint of RQ, making this line segment to be equal to that line segment. Now, this is where the LT produced intersects OQ becomes a very important thing, because it means that the whole line, which is OU, is actually parallel to LR. So as a result, this angle L3 will be equals to U1, right? Because that will make my Z, right? Remember, alternate angles is more like a Z, you see. So that's where that is. And then I can also try and say this angle, which is R1, it is equals to Q3. That's also alternate angles. And then I have one pair of 2 sides that are equal, which then makes it a congruent triangles. But let's look at this in terms of a nicer drawing of how this is going to be seen. So I know that L3 is equals to U1, as I said. This is all because of alternate angles. Even R1 and Q3, alternate angles. T4 and T2, that's just vertically opposite angles. This is just to show you the equalities that I know based on what I am told, right? Not that I'm going to use all of them, because I can't use 3 angles. That will mean similar and not congruent. Now, what do I want to prove that is congruent to something else? I want to prove that LRT is congruent to UTQ, right? If I can prove that, then I will prove that TU is equals to TL, which will make it diagonals bisect each other. Then I will know that it is a parallelogram. So let's just look at that. Now, I just want to draw a table here so we can see our reasons properly. Now I know that my statement, my reason is there. I know L3 is equals to U1, right? This is equals to U1, and my reason for this will be alternate angles, and this is because my line LR is parallel to QU, right? And then I also know that my R1 is equals to my Q3, and this is also because of alternate angles, where my line, now we are no longer using the same line, right? So my R1 and Q3, oh, it will also be the same line, right? Which is LR and QR, by the way, QU. So this is LR parallel to QU, right? Then from this, I can then say that the RT, right, is equals to TQ. The sole purpose of this is because I know I was given from the statement that that line is bisected by the point T. So as a result, I will then say that triangle LRT is congruent to triangle. L goes with U, R goes with Q, and therefore that's UQT, right? So it will be T again there. And then remember, it's angle, angle, side. So this will be angle, angle, side. Because of this, I can then make a claim that my LT is equals to TU. And then this will just be from congruency, Now, just to interest you about something, normally there are some textbooks that are a bit sophisticated where they say this is C, P, C, T, C, right? Now, I'm going to explain this. Please pay attention. The C stands for congruent, the P stands for parts, this stands for congruent, triangles are congruent, right? So in simple terms, I can change this one to E. I will say congruent parts of congruent triangles are equal. You see, so that's one of the reasons that you can use if you want to just shorten it. But the very short way is just to say from congruency. So as a result, I will then say my LQ UR is a palm, right? And my reason for this will be diagonals bisect each other. Diagonals bisect each other, right? We'll just say bisect because bisect would simply mean each other. Now, what they want us to do is to prove that my OQ here is equals to QU, right? But firstly, what do we know? We know that OQ is equals to LR, right? This will be opposite sides of a palm, right? Because we were told that LRQO is a palm, right? Opposite sides of a palm. And then what do we also know? We also know that the LR is equals to QU, right? This is also opposite of a palm because we just proved that that quadrilateral on my right is a palm as well. So it's opposite sides of a palm are equal, right? And then as a result, since both of them are equals to LR, it will then make OQ to be equals to QU. Then you don't normally need a reason because it's just deductive reasoning, right? But you can just say if you want to understand why that is the case, both equals to LR, right? You can see that OQ is equals to LR and QU is equals to LR. So it means both of them will also be equal because LR is like the common side that both of the sides are equal to. Now, a bonus question, I'm just going to show you what I would like you to do here, and then I will leave you guys to then practice it by using everything that we've done in this lesson. So here they're saying in a quadrilateral RSTU, the diagonals intersect at X. They don't bisect, they just intersect. Because we know that Rx is equals to Sx, right? Which will be Rx, that's that line there, and this is equals to that line there, right? We also know that Rs is equals to Ru. Rs is equals to Ru. Now, how can I then use that to try and prove that RSTU is a parallelogram, right? RSTU. So actually the U and the T must swap positions, please. Because remember I said the order matters, right? RSUT. How can I then prove that RSUT is a parallelogram? Now, to show you the diagram again, just remember, this is how my diagram is going to look, right? Now, if I have these adjacent sides to be equal to each other, and I have these two diagonals, right? These parts of the diagonals to be equal to each other. This kind of introduces the concept of a rhombus. Now, that's where I'm going to leave it because I want you to think about that. So, remember, Rs is equals to Ru, Rx is equals to Sx, and this I am saying kind of introduces a rhombus, which I want you to then try and think about clearly. Introduce a rhombus, right? Then you need to think about how can I then use this to try and prove that the whole shape is actually a parallelogram. Just remember that my U and T must swap positions, right? So it's RSU, it's RSTU, oh yes, so this one is the correct one, yes. It was the only that side where they needed to swap positions because I think it was just a typo there. So that's what I want you guys to do, but I'm going to leave that with you because I know for a fact you are capable of doing it. Now, just to summarize what we've looked at so far, please make sure you are very familiar with the properties of a parallelogram. You also need to know how to prove a random quadrilateral to be a parallelogram based on the properties of what a parallelogram is. And then lastly, you must show triangles to be congruent in order to talk about sides being equal to one another, even angles being equal to one another. Guys, I really hope that has clarified a few things on how to prove a quadrilateral, but I need to love and leave you. And remember though, I don't leave you with nothing. I always leave you with my wonderful words that mathematics is food for the soul.